Okay, let's look at the stadium seats question. A pretty popular question. You see this. I've seen this on a few standardized tests, even variations of this. And this problem can be done rather than just brute force adding all of these numbers together. This is a problem involving an arithmetic series. How do we know? It says in a section in a stadium has 20 seats in the first row. So the first row has 20 seats. Second row has 25 seats. So the second term has 25 seats, increasing by 5 seats each row. That tells us this is an arithmetic series, right? What do we say? Arithmetic series model linear behavior. What are linear models? Linear models have a constant rate of change. 5 seats each row. Okay? And it says that there are a total of 47 rows. So how many seats are in this entire section of the stadium? They want us to add all of these together. Now, could we list all 47 rows? Yes. That would take a long time. That's why we have that shortcut summation. The summation of 47 rows is equal to, right, starting with the first row, is equal to 47, the total number of rows we're going to add together, divided by 2, times the number of seats in the first row, or the first term, which is 20, plus the number of seats that are in the last row. Now that's where we have to do a little bit of background work, right? If there are 47 rows, we need to figure out, that's what's going to go here, that last number in the sequence, in the sequence or the series here. So we have to have a better way to do that. Well, we said this is a linear model, which means it's an arithmetic series. Let's come up with the rule, so I can just use the rule to come up with the 47th term, right? You know at this point, or at least you should know at this point, that when we're finding an arithmetic rule, right, we have d times n plus c to get the overall value of each term by plugging in n, okay? D is the common difference. What's the common difference? 5. So we know this is 5n, okay? Plus c. What is c? We've talked about this before as well. C is a1 minus d. It's the quote-unquote, it's the zero term here. The zero term, if we subtract the common difference from the first term, we get 15. See if this makes sense, okay? Would the first term, if I plugged a 1 here, would the first term be 5 plus 15, which is 20? Yes, it is. What about the second term? If I put a 2 here, 5 times 2 is 10. 10 plus 15 is 25. So this is the rule that defines where these numbers come from. So what would be the 47th term in this series? We put a 47 here. That's 5 times 47 plus 15. I think that's 250. My math could be wrong. Pretty sure it's 250, which is equal to 47. So now I can calculate the sum. Sorry, didn't mean to jump around. Now I can calculate the sum. I needed to know what the 47th term was. The 47th term, once you do that calculation, is 250. I know the first term is 20. I know there are 47 terms in the series because there are 47 rows that I'm trying to add together. Calculate this. I can't do that in my head, but you guys can. You guys have calculators to figure that out. Whatever 23.5 times 270 is. Okay, again, how do we know? Let's recap. How do we know this is arithmetic? Because it has a linear pattern to it. 5 seats get added each row. Constant addition, right? That's an arithmetic series. Addition or subtraction, right? That's a constant. That's a constant rate of change, so we know it's linear. We can come up with a linear rule that models how these seats are being built into that section, if you will. So we end up with this model for the series. We know the first term is 20. We need to know the 47th term. So we plug 47 into this model. We get 250. We know the first term, and we know there's 47 terms in the sum.